Biofeedback technology and data forecasting are two distinct concepts, but they can be interconnected in certain applications. Let's explore each of them individually. Biofeedback technology involves the measurement and analysis of psychological or physiological signals from the human body to provide individuals with real-time information about their bodily functions. These signals can include heart rate, brainwave patterns, skin conductance, muscle activity, and more. The objective of biofeedback is to help individuals gain awareness and control over their bodily processes for therapeutic, performance enhancements, and or self-improvement processes or self-improvement purposes. Biofeedback devices typically consist of sensors that detect physiological signals, a data processing unit, and a user interface that provides feedback to the individual in the form of a visual or auditory cues. By observing the feedback, individuals can learn to regulate their physiological responses and achieve the desired outcomes, such as reducing stress, improving focus, or managing pain. Applications of biofeedback technology are broad and include areas such as healthcare, sports performance, mental well-being, and stress management. For example, biofeedback has been used in the treatment of conditions like hypertension, anxiety disorders, chronic pain, and attention deficit hyperactivity disorder, ADHD. Data forecasting, on the other hand, involves the use of historical data and statistical techniques to predict future outcomes or trends. It is a method of analyzing past patterns and using them to make informed predictions about the future events or behaviors. Data forecasting can be applied to a wide range of domains, including finance, weather forecasting, sales forecasting, demand planning, and resource allocation. In data forecasting, various mathematical models and algorithms are employed to analyze historical data, identify patterns or trends, and make predictions based on those patterns. These models can range from simple techniques like moving averages to more complex methods such as regression analysis, time series analysis, or machine learning algorithms. Data forecasting can be a valuable tool for decision-making and planning in both business and scientific contexts. By using historical data and forecasting methods, organizations can anticipate future demands, optimize resource allocation, and make more informed decisions. Integration of biofeedback technology and data forecasting. While biofeedback technology and data forecasting are distinct concepts, there can be instances where they intersect. For example, in certain applications, biofeedback data can be used as an input or feature for data forecasting models. By incorporating physiological signals such as heart rate variability or electrodermal activity into predictive algorithms, it may be possible to forecast certain outcomes related to an individual's health or performance. In the context of healthcare, biofeedback data from patients, such as vital signs or physiological responses to treatments, can be combined with historical data and forecasting techniques to predict the effectiveness of certain interventions or the likelihood of future health events. However, it's important to note that the integration of biofeedback technology and data forecasting is highly dependent on the specific application and the availability of relevant data. Furthermore, the accuracy and reliability of any forecasts or predictions would depend on the quality of the data, the appropriateness of the forecasting models, and the validity of the assumptions underlying the analysis. In summary, biofeedback technology focuses on real-time measurements and control of physical signals, while data forecasting involves analyzing historical data to predict the future outcomes. While there can be instances where these concepts intersect, their integration depends on the specific application and the data availability.